Ba-dum-bum. That's for Richard because he said my intros were too boring. Hello guys. So this is your quiz corrections part 2. Sorry, I'm in a restaurant, so I hope you can hear me okay. Okay, so here we go. I already started the first part of the explanation in the previous video, but I do want to emphasize for number 6 and 7, it's the same for both versions. An exponential graph increases when the what? Okay, here's an exponential graph. What has to be greater than 1? Okay, I got all sorts of different answers. You said the x, the y, the slope, the exponent. We need this guy. What is he called? Not the exponent. This is called the base. Okay, so the base has to be greater, sorry, I'm going to just write messy, than 1. So in other words, you could have said b has to be greater than 1. Okay? So make sure you're using the proper vocabulary. An exponential graph decreases when the base is less than, wait, is greater than 0, but less than 1. Okay? Or you can say between 0 and 1. Or you could have said 0 is less than, 0 is less than b is less than 1. Okay? If you think about it, that means b on the number line has to be between 0 and 1. Right? It cannot be 1, it cannot be 0. So some people said it like this. They said 1 has to be greater than b is greater than 0. But in America, we like to start with the left first and then the right. So please don't do it like that, okay? I saw some other funny things like this. Okay? So I don't know of a number that is less than 0. I don't know of a number. Yeah, that makes no sense. How can you have 0? So basically it's smaller than 0 and smaller than 1. Well, yeah, that does make sense, but it doesn't help us. So don't do that, okay? All right, good. Hold on for a second. I have to pray and eat. Okay, so that deals with number 6 and 7. I'm going to clear that. All right, number 8, it says state the argument. Some of you guys read this wrong and you started to argue with me. Okay, that's not what I meant when I said state the argument. Okay, the argument, if you watch my other video, I'm not going to explain much because I already explained it in my other video, so I shouldn't have to explain it again. And if you're just lost, then go back to the last video that I made, notes for your flip book. But the argument is what the function is doing. Here, the function is cubing something. What is it cubing? It's not just cubing x, it's cubing x plus 3. So the argument, my friends, you should have just said the answer was x plus 3. Okay? If you had the other version, okay, number 8, the argument, well, the function was, oh, my bad. Sorry for confusing you there. This was a 2, but that doesn't matter. That means the same thing. The argument is x plus 2. Okay? Now the other one it was a square root function. It was square root of x squared plus 4. So normally the function would have been square root of x. But instead of squaring x, now we're square rooting x, we're square rooting this whole thing. So the argument is x squared plus 4. Some of you guys actually thought that I wanted you to argue what about this function is true. No. That's not what the argument meant. You need to go back to your notes and look up what does argument mean. Okay? Number 9. Simplify using the rules of exponents. So some of you had the problem that said a times a to the b. If you had the other version, you had a to the 0 times a to the b. Okay. What does this mean? This means, how many a's do I have here? There's like an invisible 1. And the rules of exponents that say if you have the same base and you're multiplying by the two exponents of the same base, all you need to do is You have the same base. But now how many times are we multiplying? Okay, here you have 1a. How many a's do you have here? You have not 6 of them, this is a b. You have b of them. I don't know what b is, but it's a number. So I have b of them here, and I have 1 of them here. In total, how many a's am I multiplying together? I'm multiplying b plus 1 of them. Right? I just need to add the exponents. Okay? So for example, if this was, you know, 1a, and that was like 5 a's, then what is that? That's 1a over here, and this is 5 of them. So in the end, how many a's do I have? I have 5 and 1. I have 6 a's, right? A. In other words, I have 6 a's. And the shortcut is, all I have to do is add these numbers. That's if I have the same base, okay? You should know that by now, okay? Similarly here, if I have, okay, I have 0 a's, and I have b number of a's. So in the end, how many a's am I multiplying together? 0 plus b of them. Well, what's 0 plus b? It's just b. So I just end up with b of them. Okay? Another way you could have thought about it is, well, what's a to the 0? What's anything to the 0 power? This is 1. And what's 1 times a to the b? It's a to the b. So whether you do it this way or this way, you're going to get the same answer. Good? Good. All right. Number 10. Moving along swimmingly because I have to eat my dinner. And yes, teachers eat dinner too. Okay, so m times x plus y. This one asks you to factor. Okay, squared. Okay, how many, you guys had different versions. This is version A. This is version A. Okay, well, notice that there's an x plus y here and an x plus y there. So I'm going to, factor means to separate all the factors. It doesn't mean to distribute. If you did that, that's going backwards, okay? That's expanding. You need a factor. If you take x plus y out, what's left here? Just the m is left. And this one already got factored out, so just the m is left. Oops. Okay. Now over here, this is x plus y squared, but if I take an x plus y out, then I'm just left with one of them, right? So now think about it. This is separate from this, okay? And so this can be combined, but there's not much to combine, so there's your final answer. Now, wait a minute. If you did not have the parentheses like this, then you got it wrong, because if you just leave it like this, according to PEMDAS, you have to multiply first before you add. And that's not what we wanted to do, right? So if you left it like this, you got the entire question wrong. Why? We shouldn't get partial credit. No, this is pre-calculus, and this is an Algebra 1 level thing, and there's no babying, there's no partial credit. Okay? So it should have been parentheses. Okay? That's the final factorization. Alright. Number 10 for version B, okay, was, okay, 2 times 3x is good, right? Isn't it good? 7 squared plus x minus 2 times 3x minus 7. Okay, again, do you see a common factor? Yeah, both of these terms, this is one term, this is another term, okay, have a 3x minus 7, a factor of 3x minus 7. So I'm going to factor out the 3x minus 7. Okay, and what's left on the inside? Well, if I take out a 3x minus 7 from this term, I have a 2 left. But there's also another 3x minus 7 because it was 3x minus 7 squared, and I only took out one factor of 3x minus 7. So I have that. And then if I take out the 3x minus 7 from here, I'm still left with the x minus 2. Okay? So let's bring this down. Let's not forget. Now, okay, remember, you gotta have the parentheses. Otherwise, you're telling me to first multiply the 7 to everybody and then 3x later. Okay, you don't want to do that. So you need the parentheses. See, I almost forgot it too. Okay, so now I'm going to distribute this. So 6x minus 14 plus x minus 2. And I could simplify that. So 6x plus x is 7x. Negative 14 minus 2 is 16. And there's my complete factorization. Good. If I'm going too fast, this is the video. Stop, pause, rewind. Okay? Otherwise I'm going on because I have to eat dinner. Oh, yes. Okay. Going back to version A. Number 11. Simplify using the rules of exponents. N to the negative 1 times n to the negative 2 to the third power. Okay, remember, when you're doing it to the third power, you really can just... everything is multiplied here, so you actually can distribute that exponent. But I don't want you to think of it that way as a rule, because then it's confusing when you can and when you can't. So just remember, what are you actually doing when you're doing that to the third power? What does it actually mean? It means whatever's in the parentheses, you have it multiplied 3 times. Right? Because it's the third power. And I know you're like, want to be lazy and you're like, oh, that's too much writing. But I'm telling you, and the end is going to pay off. So let's think about the m's. I mean, the parentheses doesn't matter because everything's being multiplied. So you have m to the negative 1, m to the negative 1, m to the negative 1. Earlier we talked about when you have the same base, you can just add the powers. So you have m to the negative 1, negative 1, negative 1. That's m to the negative 3. And what about my n's? Okay, negative 2, negative 2, negative 2. So now I have n to the, what's negative 2 minus 2 minus 2? That's n to the negative 6, isn't it? Isn't it? Okay. So now I have this. Okay, as my final answer. If you think about it, I definitely could have just distributed that 3 and done n to the negative 3, n to the negative 6, but I want you to know why. Okay, it's because of this. Okay, so there's your final answer. All right. 11, version B. Okay, 2x to the negative 1 squared. Okay, so many people got these wrong. People. Okay, first of all, first thing I notice is that x to the 0 or anything to the 0 power is just 1. So that's an invisible 1. It might as well not even be there, right? Good. Alright, so this, okay, this squared, this really means 2x to the negative 1 times 2x to the negative 1 because I'm squaring it, right? And over here, I just have 2 times 1, which is just 2. Alright, let's put all the constants together. What's 2 times 2 times 2? It's 8, right? So forget that. I'm just going to write 8. And what's x to the negative 1 times x to the negative 1? Remember, you could add those exponents together. That's 8 times x to the negative 2. Or you could have said 8 over x squared. Both are acceptable answers. Okay? Next. Second to last, version A of number 12. I asked you to use the rules of exponents to simplify this. Now you know there's a rule that you could actually just multiply these together and get 2 to the negative 20, but I would much rather you understand why and know the rule. To understand why that rule works, which is, this is really asking you to do 2 to the negative 5th times 2 to the negative 5th times 2 to the negative 5th times 2 times the negative 5th, the fourth power, right? Well, we know that we have the same base, we could actually add the exponents together, which is negative 5 minus 5 minus 5 minus 5 is negative 20. Okay, but even that is a little bit of a shortcut. Okay, this is really asking you to do 1 over 2 times 2 times 2 times 2 times 2. It's 1 over 2 times 2 times 2 times 2. You know, there's a dot there. And we're doing it 4 times. Oh my gosh, but my hand gets tired. And I realize, what's the point? There's a shortcut. What is a shortcut? Well, in the end, oh my goodness. I'm going to have 1 times 1 times 1 times 1 on the top. And then you have my 2 times 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 2. How many 2's am I going to be multiplying? Well, there's 5 each time, and there's 4 sets of 5. I'm going to have 22's. That's why I'm going to have 1 over 2 to the 20th. Or 2 to the negative 20. Okay, I really hope that you understand what I'm talking about. Okay, my friend is laughing because, see, she just feels like this is so easy. Why do I have to explain it? It's so obvious, and you guys are pre-calculus, but we won't talk about that. Okay, so, sorry, I don't mean to be disparaging at all. Okay, so you guys are wonderful. Okay, well, when you work hard, that is. Okay, version A of number 12. Okay, I have 2/3 to the negative 2 power. Okay, now remember, I'm going to first deal with the negative. What does the negative ask you to do? It actually asks you to do the reciprocal, right? So you could either do 1 over 2/3, which in the end you have to flip, it gives 3/2, or you could just go ahead and flip the 2/3 and it's going to be 3/2. So it's the same thing as 3/2 squared. The squared is still there, but now we took care of the negative, right? We took care of the negative by actually flipping the fraction. Okay? Now, what's 3/2 squared? That's 3/2 times 3/2, which is 9 over 4. Or you could have done a shortcut where you square the top, you square the bottom, so it's 3 squared over 4 squared, which again is 9 over 4. Alright, I'm going to enjoy my dinner now. Oh, go ahead. Oh, thank you. Oops. Alright. Okay, one more thing I was going to tell you guys is on the quiz week 3. I went over most of the answers in class, but I didn't go over number, it was number, okay, I can't find it. But anyway, it says something about there's a function like this, and we want to stretch it, but do a vertical stretch of 3 and flip, so like that. The question is, where should that negative 3 go? Should it go here, or should it go here? Right? And I talked about this in class with some of you guys. The question is this a vertical stretch, or is this a vertical stretch? Remember, when we're vertical stretching, we want to take that function and we want to multiply it by a factor outside the original function. So this would not work. It would have been this, because this is the outside. Okay? Alright, have a good evening. Message me if you have issues. See you tomorrow.